Okay, so for box 3, what is one of the things that you need to find?
Critical numbers.
Okay, and critical numbers are the only place where the graph might be changing direction. That's why that's good for that. And critical numbers are when the first derivative is 0 or undefined. So I'm going to guess that some of you guys did this. But what's wrong with that?
It's the second derivative.
Right. They actually gave you the first derivative this time. That completely changes your approach. That one little tick mark completely changes whether you don't even have to take a derivative on this one. You need to know that critical numbers come from when the first derivative is 0 or undefined. So that looks like 0 and 1/2. To visualize this, and just to make good habits so that we do this correctly on FRQs, make a little line chart. And again, you need to understand why critical numbers are important so that you understand why we did that. Critical numbers are the places that might be changing directions. This guy is not going to change direction at x equals 1 because x equals 1 is not a critical number. These are the only places that might be changing direction. So to know the direction to the left of x equals 0, plug in any number less than 0 into the derivative. We would get a negative minus 2, which would be negative. To know whether it's increasing or decreasing to the right of this one, we need to throw some number bigger than 1/2 into the first derivative. That would be like 4 minus 2, which is positive. And the test in here, this one's a little bit harder because between 0 and 1/2, you're going to have to pick something like a fourth. Less than 0, bigger than 0. Okay, if I try to plug in a fourth, again, and sometimes it's easier to look at the factored form, by the way, than this form. Plugging in a fourth here and here and trying to figure out if that's positive or negative might be a little bit harder, but you could also plug it in here. Plugging in a fourth here gives me something positive. Plugging in a fourth here gives me something positive. A positive times a positive is positive. Okay, so this line chart is very good to let me know that there's a relative min at x equals 0, but this question's not even asking that. It wants to know when is it increasing. So that's going to be from 0 to what? Is it increasing at x equals 1/2? It's 0 at x equals 1/2. So it's really increasing from 0 to 1/2, and then increasing again from 1/2 to 1. At x equals 1/2, it's not increasing. At x equals 1/2, it's either undefined or vertical or horizontal, but not increasing.
Would it be 1/2 to infinity?
Yes, 1/2 to infinity. Thank you.
If you plug 1/4 into the derivative, isn't it negative?
If I plug in a fourth here, that's positive. If I plug in a fourth here, that would be negative. You're right. Yeah, sorry. That would be negative. So the only increasing time was 1/2 to infinity. Okay. That look better? Now, I'm thank you for catching that mistake there, because I think it's good for y'all to see from class yesterday. There's lots of little times. It's better to do slow quality work than it is to try to fly through and make a bunch of mistakes and have to redo a bunch of stuff. So just like plugging in this, I plugged it in just a little bit too quickly, which almost made me get the wrong answer. And I'm willing to bet that the answer I wrote down may actually be one of the answers on the worksheet, because they do a pretty good job of that. Okay, are we all in agreement that this is the increasing time now?